Hello everyone, hope you all are doing well. And today we are going to be working on building a complete weather app for WatchOS in SwiftUI. So let's go ahead and take a look what we are going to be building today. So we will be building this WatchOS app where Watch will show user's current location and will show the weather of the current location. So we'll display the name of the place along with the current weather conditions. For this example, we'll be using a simple weather API from Little Software, and reason we will be using this API because it's very small and it doesn't require any kind of authorization or registration for the API keys and stuff like that. So all you need to do is basically get the coordinates for the place and you can fetch the weather forecast. So if you go into the features and location, and if I change this location to Apple, the location is going to change and weather is going to be retrieved for this location for Cupertino. That's where Apple is located, and it's going to display the current weather condition for the location. Okay, like this, you can actually, if you have any other preferred place, you can simply choose the custom location and then basically add the location parameters here. For example, I'm going to change it back to New York, and as you can see, it's currently raining over there and it's 45 degrees. So that's how the changes are going to be monitored. And if you can see, like, our UI is responsive, like, as we are changing the location is being monitored and the weather conditions are changing along with that. Now we will also be using another API to perform reverse geo lookup to get the location information for the city, like, for example, like, if it's called reverse geo coding, and what we're going to be doing is we're going to be sending the coordinates to this API, and it's going to give us name of the city, state, country from the coordinates that it has received. All right, so this is going to be the project for us today, and coming up next, we're going to discuss about the learning objectives for the course. All right, so before we get into the course and discuss the learning objectives, I want to take a moment to talk about the YouTube channel itself. So if you haven't already, please go ahead and subscribe, because when you subscribe, it gives us motivation to create new content, and there's a whole bunch of things that actually you can get from this channel. First of all, we frequently upload new video tutorials, so you get access to you get notifications about those. And coming back to the channel itself, like, there's a whole bunch of resources that are out there within the channel itself. Like, we have a whole section for complete apps. We have like lead code interview questions specifically focusing on Swift and iOS. We have data structures and algorithms course hosted here as well, where we go take a deep dive into data structures from Swift's perspective, not SwiftUI, but Swift perspective, like, from the iOS development perspective. There's a whole bunch of videos on SwiftUI itself, like, SwiftUI 2.0 specifically, a lot of them, and SwiftUI. So you get to learn a lot of tips and techniques, that to apply for your own apps. Okay, and there are, like, other complete app tutorials as well that are divided into multiple videos. So I've created playlists for those. There are some Flutter related videos as well, so you can go into the videos if you're looking for, like, the latest and greatest video, and if you're looking for a playlist, just go on to the playlist section and check out there. if you have any questions or if you need anything, just feel free to hop on to devtechie.com. That's where you'll find our email address. So drop us an email, and we will respond to your questions as soon as possible. Okay, so I just wanted to discuss quickly about the channel itself, and thanks again for your continued support. And let's go ahead and hop back into the video to discuss about the learning objectives for the course. All right, so let's go ahead and talk about the learning objectives for this course. So basically, we are definitely going to be learning about WatchOS and SwiftUI. We will be learning about location permissions and location tracking, along with location access, because we're going to be tracking users' location so we can update the weather condition according to the location. We're going to be talking about info.plist and how you can add your location tracking permissions and what's needed basically from the privacy perspective to be added into info.plist. We'll talk about how to use CL Location Manager and location tracking on WatchOS specifically. Well, it's actually not very different from the iOS space. So if you already have the experience using CL Location Manager, then it's going to be pretty close to that. We're going to be creating our generic network manager so we can actually make our API calls, networking API calls, and reason we're going to create them as generic so we don't have to write the same code over and over, and as long as our API and our classes conform to Codable protocol, we'd be able to parse the responses easily using this network manager. We're going to be working with, we're going to be looking at networking and making API calls from WatchOS itself, and we'll be looking at the use of on-receive observer, which is actually a combined publisher observer, to monitor the changes in location and how to respond to those. We will be working on reverse geocoding for coordinates, so you can reverse geocode your coordinates into the readable city names and state and country names. Okay, so these are not all. Along with these, you're going to be looking at a whole bunch of modifiers, SwiftUI views, how to better structure your code, and etc. Those come for free along with the the working when you're actually building this project. So yeah, I hope you're excited to hop onto the journey, and let's go ahead and get started by structuring our project and get it ready to build out this complete app within WatchOS using SwiftUI. All right, so let's go ahead and get started. We're gonna first do the setup. So first of all, if you have not created any WatchOS app, the app creation part is rather similar as you create your iOS app. So you simply create a new project. So you can use a shortcut. If you have Xcode open, you can use shortcut Command Shift N, and that will actually open a new project template, and what you gotta choose is this WatchOS tab, and we're gonna be working with WatchOS Watch app, which is gonna be basically an extension, and you simply gonna click next. After that, give your product name and your theme if you have any, but you can leave it none if you don't want to define a theme. The organization identifier is usually the reverse domain name that's unique to your app, and the interface we're going to choose SwiftUI. Lifecycle we're going to choose SwiftUI app. Language is going to be Swift. Go ahead and uncheck this include notification scene. We're not going to be working with notifications in this case, so just uncheck that. Click next, finish, and you are going to be landing right here where I am. All right, so with that, our project is pretty much empty slate at this point. There is not much going on in this. So I guess first thing we can do is we can start structuring up, creating a structure a little bit like, for our files to live in. So I usually like to take this time to basically create some folders, so I know, like, which item is going to go in which folder. So we're going to create one for views where all of our views are going to go. We're going to create another folder for our models, and we're going to create a folder for the managers. So any of the download manager, networking manager, location manager, all of those are going to go inside those. Now I'm going to leave all these three, like, right at here, because this one is going to be basically the entry point. We're going to simply call our main view from the content view, and that's how we're going to launch your watch weather app. Basically, watch weather is the name of the project, and app is the app, representing that this is the app. Is basically your launch point, your entry point, because it's attributed with the main attribute or main property observer to indicate that this is the starting point for your app. All right, complication controller, we're not going to be working on that, so don't worry about that. Other than that, you have assets. If you have any assets you want to include, go ahead and include it over here. And let's go into the info.plist. Okay, this is where we're going to be basically including the privacy keys. So what you're going to do is you're going to simply click plus here to add a new key, and what you're looking for is privacy. And under privacy, what we wanna get access to is location when in use, and location always and when in use. So there are two keys that we need to add. So we're gonna add location always and when in use, this one, and we're gonna go back and add another key, and this one is going to be location when in use. Location when in use description. So make sure you have these two keys added. Now if you don't add that, what's going to happen is basically your app is going to crash on launch, because Apple is going to complain that you need to, in order to use the location services, you need to have the usage description within the info.plist. Okay, so here we need to put a description that actually explains user what we're gonna do with their location. So we're gonna just say need your location to display weather conditions. Okay, we're gonna simply copy and paste the same message for both. Okay, all right, so with that, we're gonna go ahead and save. Let's go ahead and build your project once to make sure that everything is working and building. Now our project is ready to dive in and start coding. So we're gonna start with the managers. So first thing I want to create is a network manager, because that's going to be something that we're going to be using more often. So let's go ahead and create a generic network manager first, so we can start making our API calls. And from there on, we're gonna start working on, like, location manager and weather manager, etc. To basically retrieve the information about the location and the weather. Okay, so let's go ahead and create our network manager. So what I'm going to do is I'm going to select the managers folder and press Command N to open the new file dialog. And we're going to add a Swift file. So select Swift file, click next. Basically, we're going to name our file as network manager. Okay, make sure that you select the correct target. So this target is going to be the extension, the one that has E in it, and make sure it actually reads as WatchKit extension. Okay, with that target selected, just go ahead and create your file. Okay, so what we're going to do here is we're going to create a generic network manager that is going to be constrained to a codable protocol. So anyone who wants to use this network manager have to conform to codable protocol, and we can, with the help of this network manager class, we'll be able to make network API calls. And reason this is generic, so we can reuse these with different kind of classes. So you're gonna see the usage of this when we start creating our weather manager, and when we start getting the response for the reverse geocoding. Okay, so let's go ahead and create a final class, network manager. Now we're going to constrain this to, we're going to have a generic T which is going to be constrained to codable. So any class or a struct basically conforming to codable protocol would be able to use this network manager. And we're going to say func fetch. So the only function that's going to be in there is going to be fetch, and we're going to say fetch for URL. So user has to supply the URL from which they need to fetch something. There's going to be a completion block which is going to be escaping, and it is going to return a result. So we're going to use the result type to return our response. So it's going to return type D and a network error. Now, network error does not exist. It's going to be an enum that we're just going to create. So let's go ahead and create an enum here. We're going to call this network error, and it's going to be conforming to error protocol. And we're going to have some cases here. So first case is going to be bad response. So in case when we receive bad response from the API, we're going to use this one. We're gonna have another case for wrong status code, and this is basically gonna supply the code as well that we have received. We're gonna have one for error, a generic one generic case for error, which is gonna supply the error string as well. And we're gonna have a decoding error. So this is the error that we would encounter when we have some problem when we run into some problem during decoding. So we want to throw this error and provide some more information to the caller that this is what happened. And we're going to have empty data error that we're going to send if the data is empty. Okay. Now we're gonna create the body for our network manager, and this body is gonna be pretty simple. It's gonna leverage the power of URL session, and we're gonna use shared session dot data task, and we're gonna use the one that actually takes URL and have a completion handler. So we're gonna give it the URL that we have received, and the completion for the URL session is going to give us data, response, and error. Okay, and now we're going to start basically checking for the cases where an error could occur, or when we successfully receive the response. So we're going to simply put guard statements here. So guard error. So if error is nil, then only proceed, otherwise return a completion with failure. And we are going to return the error this time because I'm going to provide what error exactly has occurred, and we're going to return from here. Okay, now second case of guard is going to be when we will try to convert our response, which comes as URL response, into HTTP URL response. If we are successfully able to convert that, we're gonna basically continue forward. Otherwise, we're gonna return a failure with bad response error, and we're gonna return from here. Now, using that HTTP response that we have just retrieved, we're gonna check the status code. If the status code for the API is 200, that means everything is okay and we actually did get the response back. Then it's all good. Let's proceed. Otherwise, throw or return a completion with failure, and we're gonna this time say it's a wrong status code, and we're gonna supply the status code that we have received and return from here. Okay, this is just we are safeguarding ourselves from any potential crashes or errors. So you're gonna say we're gonna retrieve the data now. Next, we're gonna say if guardlet data is equal to data, if we are able to unwrap that. If the data is nil, then we want to actually return a completion block of empty data from here. Okay, now when we reach at this point, this means that we have actually got the error sorted out, or there's no error. Response is looking okay, and data is also looking okay. So we can actually use do try catch. So we're gonna say do let JSON is equal to try, and we're gonna use JSON decoder dot decode. And what we're gonna decode from? Well, we're gonna be decoding from this type that has been supplied to us. So we're gonna simply say t dot self. Okay, and from is gonna be the data that we have retrieved and unwrapped from here, this guard statement. Okay, now, once we have this JSON decoded, we wanna call dispatch queue dot main dot async, because everything that was happening so far was on the background thread. URL session is called on the background thread. So we're gonna simply say, okay, move to the main thread and call a completion block there with success. And if you notice, the success takes decodable and encodable. And if you look at our case, the success result type is T, and because T conforms to codable, which is basically a combination of decodable and encodable protocol, this means that anything that conforms, any object that conforms to these two protocols or codable protocol would be able to we will be able to supply that over here. So we are simply gonna supply our JSON here. Okay, now reason there is an error that's showing up because we haven't put the catch statement here. So let's go ahead and put the catch statement. And if something happens, that means, like, there's an error. So we want to show a failure, and this time it's a decoding error because that's what we were doing here. So if this try fails, that means there was a decoding error, and we want to actually catch that, and we want to return that decoding error back to our caller. Okay, now one important thing about URL session that I personally always forget is calling resume on it, and that's the way to start your network calls. So make sure you call resume right at the closing bracket of your URL session. Okay, and with that, let's go ahead and build this project. Everything should still build, and we should not have any errors. So we are still building successfully, so that means everything is looking good. So what we're going to do next is basically we're going to create our weather manager, and we're going to use this network manager to basically make a call to the weather API and retrieve the weather. So before we actually create the weather manager, we're gonna need some weather model and weather responses and stuff like that. So we're going to be checking out the API that we're going to be using first, and then we're going to be creating our model. Next, we're going to be creating our weather manager to make the API call. Okay. All right, so let's go ahead and take a look at what we're going to be working with the API wise. So if you go to this URL, lil software, so it's lil.software/API, you're gonna land on this page. This website actually provides APIs that are pretty straightforward. Like, there is no registration required for any of these, or no API key, and you can simply access them via URL. Okay, so there are, like, various different APIs. So there's one for weather itself, and there's one for news, and you have stocks as well, and I think they have one more coming up. That's for flights. Okay, so we're going to be concerning ourselves with the weather API. So let's go ahead and click on that one. And if you notice, this is the URL that you're going to get. And first of all, for the URL, you are going to pass the latitude and longitude for the user. Now, this latitude and longitude you can easily get using code location by tracking user's location, which is why we need user's location permission. So once you get that, we're going to construct this URL and we're going to get this response. So what we're going to do next is basically create a model for this weather response and a weather model, and from there we're going to actually create our weather manager first, and then the location manager, which is going to be tracking down the user's location, so we can pass that into the URL to get the weather information. Okay. All right. So let me close this and go back to the project. And we're going to add, the first thing we're going to add is going to be the weather response model. So let me go ahead and press Command N, and we're going to select a Swift file template this time, and we're going to call this one weather response. Okay, and this is going to be simple struct weather response. It's going to conform to codable protocol, and it has one parameter or one key, which is forecast. Okay, and that's what we get from the API, and it returns an array of something, and that something is going to be called weather model. So we're going to create a new file, and that file is going to be called weather model. So let me create the model here, and then we're going to move it into the file itself. Okay. All right, so weather model is again going to be conforming to codable protocol. We're going to get name. So name is sort of the key in the response. So I'm going to use name, temperature, unit, description, and conditions is going to be a string, which is basically going to be a computed value. Okay, so this computed value is going to have a switch statement, and we're going to put the switch statement on description itself. So the API itself does not provide a clear indication of, like, whether the weather is clear, sunny, and stuff like that. I mean, it does give you inside the description. So what we're going to do is we're going to look for the keyword description, and once we have once we have actually sort of, like, looked at the description and found the keyword that we are looking for, then we're gonna return a string which is gonna act as the icon for that weather condition. So let's go ahead and look at what I'm talking about. So we're gonna work on pattern. So we're gonna say string str, where str dot lowercase dot contains. If our string contains clear, then we're gonna return sun.max. and this is basically going to represent or going to be same as our SF symbol, because this is going to help us basically display those weather icons. Okay, so I'm gonna do the same thing. So let me go ahead and copy this line right here, and I'm gonna paste it. And next is going to be rain, and we are going to return cloud dot rain, and these are basically names of SF symbol icons. Third one is going to be sunny. Then there's cloudy. We have snow. And there's storm. So we're gonna return tropical storm. That one. Okay. The default is gonna be we're gonna return sun dot max. Okay. Alright, so this is gonna be our weather condition, and this is gonna be our weather model. Okay, so let me go ahead and create a new Swift file against that, so we can actually move this code into its own file. Okay, and there we go. All right, so our weather model is ready. There's one more thing that we're gonna need, which is gonna be the coordinates. So the coordinates that we get from the location manager is CL location. And I feel like we can have our own coordinates class that will actually be populated by CL location coordinator, so we don't have to pass on CL location everywhere. Okay, so for that reason, I'm gonna create a new file, and we're gonna call this one weather coordinates. Okay, it's gonna be a simple struct. And it's going to have two properties, lat and long. That's it. Okay. So now we are ready actually for our weather manager to basically create and call the API to get the responses. Now, before we actually, so we're going to create the weather manager, which is going to basically supply the coordinates and get the weather response back. And then we're going to create our location manager, which is going to be responsible for tracking users' location. All right. All right, so let's go ahead and create our manager. So our weather manager. So I'm going to create a new file here. We're going to call this, I'm going to select the Swift file, and we're going to call this weather manager. And this weather manager is going to be basically publishing the results after finding the weather information from the API. So first we're going to import from combine. Then we're going to create a final class, weather manager. This is going to be an observable object, and it is going to publish weather response. We're going to create an empty weather response, and then we're going to have a function get weather for coordinate weather coordinates. Okay, and then you're going to have a URL, and we're gonna use the string-based URL. Okay, so once again, the API is https :/API dot lil software dot software slash weather. Latitude is going to be and longitude is going to be the coordinate dot long. Okay, we can force unwrap this because we know that we are providing a URL. Okay, so that's your URL. Now we're going to use our network manager that we created with weather response as the type. Weather response. Okay, and then we're going to call fetch on this for the URL, and we're going to get the result back. Okay, and now we're going to simply put a switch statement on the result, and we will simply put a case for failure. Okay, and we're going to print the error that we get, dot localized description, or we're going to get the success, which is basically the weather response that we get. So response, and we are simply going to say self dot response, where the response is equal to response, which is of type weather response. Okay, all right, so let's go ahead and build this. Okay, so build succeeded. I want to make sure that we have the correct endpoint, so I'm going to just copy paste that URL line from the completed code one time. Okay, so I did have like some, oh, I had HTTP, but it's actually HTTPS. Yes, so make sure like your API is HTTPS. Okay, so now our weather manager is ready to be called, but once again, we don't have the coordinates, we don't have the latitude and longitude information yet about the user. So next we're gonna create our location manager, and then that location manager is gonna basically provide the coordinates for the user, and we're going to call this API to get the response. Okay, so let's go ahead and create one more manager, and this time it's going to be the location manager. So we are simply going to call weather location manager. Right. Okay, so we're gonna first of all import from core location, because we are going to need core locations help to basically track down users current location. And then we're gonna create our final class, weather location manager, and this class is going to be inheriting from NS object. It is going to be conforming to observable protocol, and it is also going to be responsible for implementing CL location manager delegate. CL location manager delegate. Now, CL location manager delegate is the one that is responsible to get the latest information about the user's coordinates. So what happens basically when your user is moving, you can put an observer onto your location tracking and basically get the latest out of user's location. So that's what we're going to use to basically implement a function called did update location, which is going to provide the latest location coordinate for the user. Okay, But before that, we're gonna need a couple of properties. So first of all, we're gonna need a published property for city name. And for now, we're just gonna say it's San Francisco. And we're gonna have coordinate variable, which is going to be of type CL location coordinate 2D. And we're going to initialize this with coordinates for San Francisco. So let me go ahead and do that. Okay, so I just copy pasted. Now we're going to create our location manager. So this is going to be private location manager, private var location manager. Now this location manager is of type CL location manager. Okay, and then we're gonna override init. Now here we're gonna initialize our location manager with CL location manager. We're gonna call super.init, and then we're gonna say location manager dot request always authorization. Okay, so this is basically whenever this function is called, we're gonna see that permission, or user is gonna see the permission screen where the app is gonna ask user to allow the location tracking, and this is where that string that we added in info plist, this need your location to display weather conditions, is gonna show up. So once user has authorized us to basically start using their location, we're gonna simply say location manager dot start updating location. Okay, and we also want to make sure that we are, or this class is the delegate for location manager. Okay, now we want to basically somehow get the results of this location monitoring. So we're gonna implement a function called date locations. Okay, and we get locations out in this. So every time user changes the location, this function is called. So we're gonna simply say guard let location is equal to locations as else return. Okay, locations dot last, right? Location dot coordinate. Okay, so we're gonna get the last location because we get, like, a whole bunch of location changes sometimes, so we wanna get the most recent being tracked. So that's gonna be the last one in the array, so we're gonna get that, right? And we also wanna basically get the user's city once we have the location. So in order to get city, we are gonna use another API, which is called bigdata.net. So let me go ahead and show you what the API looks like. All right, so this is the API that we're going to be using. It's called api.bigdatacloud.net. And so if you go on this URL, or maybe bigdatacloud.net, um, basically you're going to be able to read through and find out. And this provides a lot of things. There's a geocoding API, networking API, and time zones, and etc. But we are going to be basically looking at geocoding. And let's see where the API list. IP geolocation API. Let's see. Okay, so all right, so let's go back and I'll actually show you the URL that we are looking at. So I couldn't find the URL. Okay, there we go. So the URL itself is api.bigdata.net/data/reverse-geocode-client ? Then your parameters, query parameters start, and you provide latitude and longitude, and locality language. So we're going to use that. Okay, so what this is going to give us is basically the location information based on latitude and longitude. So you get like in the continent, country name, city, locality, postal code, etc. So this is actually printing for Mountain View. Okay, so this is what we're going to use, but in order to use that, we need another model called city model, which is going to hold the response for this API. So we're going to create a new class, and we're going to call this one city model. Okay, make sure the target is correct, and this is going to be a struct city model, and this is going to be codable. You're going to have city, and a principal subdivision. So this is basically the state, and your country code. Okay, these three values exist inside the inside your API response. So that's what I have. So go ahead and copy paste to make sure everything is correct. Okay, so yeah, the whole model is this is the entire model. So let's go back into our location manager, and inside the location manager we will create a function, and this function is going to be called get. So it's going to be a private function, get city for coordinates, and we're going to supply location coordinate. Okay, and we're going to simply call that get city for coordinate. Okay, and URL is going to be, I'm going to copy paste this URL, and we're going to talk about it. So it's the URL string, once again, bigdatacloud.net, and then we're going to populate latitude and longitude information. Now from here on, it's simply just a call to our network manager with type city model, and we're going to fetch for the URL with the completion that we're going to get back, and we're going to put a switch statement on this result, and this is going to be case for failure, and case for success. And in case of success, we are going to use our city name and populate that with the city information that we have retrieved from the model, from the city data right here from the API. So city name dot city data dot city, comma, city data dot country code. All right, so that's about it. So that's your entire location manager. Now next up, we are going to be working basically to make this API call to see how this actually looks. Okay. All right, so let's go ahead and take a look at what our API response is gonna look like. But before that, I actually found the Big Data Cloud URL. So if you go on the bigdatacloud.com, um, you're gonna go into API list, go under geocoding APIs. And as soon as you go to geocoding APIs, there's one in the center that says free client side reverse geocoding city API. That's the one that actually we need to sort of use. So if you click on read more, this is basically gonna tell you more about the API itself, and this is the URL that I was using. So this is the URL that you need to get, and it actually asks for um, latitude and longitude. So you just need to supply those two values and you get your response back. So if you look at the JSON view, this is all the information that you get, and you can take out anything you want to. I actually use the exact same response for Mountain View, Googleplex, and it will actually even give you the postal code, etc. Um, for that given latitude and longitude. Okay. All right. So going back into our app, now we have basically this location manager created. So let's go ahead and work on our views, and then we'll be able to make the calls directly. So views are going to be rather simple. Actually, I mean, there's going to be just two views. There's going to be one for the outline. So if we go back to the app, so let me pull up the app, and I believe it's this one. Okay, so it's asking about the location permission. We're gonna say precision on, allow while using the app, and there you go. So this right here is the outline view, and this is the internal detail view. Okay, so what we're going to do is we're going to go and create the outline view first. So let me go ahead and create a new file. We're going to select SwiftUI template this time, and I'm going to name this one outline view. Okay, and after creating this this outline view, this is going to be a really simple view. It's simply going to be a rounded rectangle with corner radius of 10, and for the stroke we are going to use a linear gradient, and the gradient colors we're going to give them in a minute, but the starting point is going to be top leading and the end point is going to be bottom trailing. Okay, and let's give line width as well. I'm going to give it a 4, and we're going to add some padding as well. Okay, let's go back to the colors. So I'm going to start with purple, and going to have color dot blue, and then we're going to have color dot blue dot opacity 0.4. All right, so okay, so we have this outline view created. So if I go ahead and resume this, hopefully this is gonna build and show us how the outline view actually looks like. All right, so this is what our outline view actually looks like, and you can actually change the color to see different color combination as well. So actually red does not look that bad, and if I turn this into blue, let's see if that looks yeah, that's actually not bad. And if I let me take this out. Okay, all right, so we can have symmetry on both sides. like on two corners, so that's perfect. So let's use this one as an outline view. Okay, so next up, we are going to be creating our watch weather view, the main view that's actually going to display the weather. All right, so let's go ahead and create another view, and this is basically going to be our main view. So we're going to call this one select SwiftUI view and call this one weather, watch weather view. Okay, now this watch weather view is going to need a couple of observed objects. So two observed objects, for one for location manager. Let me collapse this. Location manager, and there's going to be another one, weather manager, like that. Okay, now next we're gonna have a Z stack, and inside this Z stack, first thing we're gonna have is our outline view, which is gonna sit on the back, and on the top we're gonna have a V stack with alignment as center, spacing as 0. All right, then we're gonna have an H stack with text as location manager dot city name. We're gonna have the line limit to be 1 and minimum scale factor, let's give it 0.005. So if the text becomes large, then we can actually reduce the size of the scale our text down. Okay, then we're gonna have our image system name, and this is gonna be paper plane dot fill. Okay, and that's about it for our H stack, the title at the top. So this guy right here is this title at the top, right? So name and the image. Okay, next we're gonna have an image system name, weather manager dot weather response dot forecast dot first dot conditions. If nothing is returned, then we're gonna simply display sun dot min, and we're gonna give it a font of title and foreground color of yellow. Okay, so it's this guy, this icon right here, the current weather conditions icon. And below that, we're gonna display our current weather conditions, so we can actually use the description. So we're gonna simply use text here, weather manager dot weather response dot forecast dot first dot description. If nothing, then you're gonna print blank here. Font, let's give it a footnote font, and for the foreground color, we're gonna give it gray. All right, then we're gonna have a text, and the text is going to be, this text is basically going to be the actual temperature, right? So what we're going to do here is we are going to use our string formatter. So let's use string interpolation with string format. So let's make sure, yeah, okay, format. And the format that we're going to follow is going to be %0.0. We don't want to display any digit after the decimal, so that's why 0.0f. And then this is going to be weather manager dot weather response dot forecast dot first dot temperature. If you look at the API itself, you're gonna find out why I'm doing first, because it actually gives you next 7 days. The API itself gives you next 7 days of forecast, but what we need is just the current day, and you can expand upon it. Basically, you can use the entire response, and you can have basically your app show more detail at the bottom and put this inside a list view or something. So you can do that. But for this demo, we're just going to use the first response. Okay. We want to add some shadow into this, so I'm going to use the other overload for shadow, the one that takes color, and I'm going to say it's going to be color.white.opacity 0.2. Radius is going to be 2, -2 to -2, and I'm going to just copy this and paste it. The only thing that I'm going to change is, first of all, the color is going to be black, and these guys are going to be +2. Okay. Now, whenever something changes, how would you go about monitor those? So for that, you can use onReceive publisher. It actually takes a publisher, and whenever an action is performed, it actually gives you the output of that publisher. So in our case, location manager has a publisher called city name, right? So we're going to observe that change on that, and we're going to say weather manager dot get weather for, and we're going to say weather coordinates lat long is going to be received from location manager dot coordinates dot latitude, and location manager dot coordinates dot longitude. Okay, so basically this is gonna get us the weather for these coordinates, right? And once we have the coordinates, we're gonna update our weather response, and whenever we update our weather response, our entire view is gonna be refreshed automatically. Okay, all right, so with that, let's go ahead and run this, and I'm going to build this out and show you as soon as the app loads. All right, so the app is loading now, and going to give it a minute. And okay, so the thing that we forgot to change was, I guess, the content view. We need to call the watch weather view. Okay, so let's go ahead and run this again, and we're gonna let it build. All right, so first thing what you're gonna see is your watch is gonna ask for the weather permission, and look at this. This is the description that you actually added. Need your location to display weather conditions, and we're gonna say allow while using the app. Okay, and as soon as we do that, there we go. Our new UI is showing up, and let's see. Okay, so for some reason, let me see what the location is. So go into your location and change it to Apple, and see if the location changes for the Apple. Okay, so it did not change. That means there is some issue. So let's go ahead and find that out. There is some issue being reported right here. So let's go ahead and find out why this is crashing. All right, so I put a debugger here on this in our weather manager. So what we are getting is the URL. So let's go ahead and go into that. So first, let me go ahead and print the URL. So this is the URL that we are getting. Okay, so first thing what I'm going to do is I'm going to try out this URL inside the browser and see if it's returning any response for us. Okay, so let's take a look. And there we go. We do have the response coming back from the URL. So that could be basically we are. Okay, so let's go ahead and put a debug point here further down under the result. And I'm going to hit continue. And okay, so there we go. Now we're going to see if we get an error. Okay, so we are getting an error. So we're going to print the error. So error. And data could not be read because it's missing. Okay, so there's a decoding issue. All right, so let me go ahead and open our model, and it very well could be some of the misspelling. Okay, so all right, so let me pull up the model one more time. So I'm gonna copy this and get the API. Okay. All right, so we have name, temperature is one of the key, and we have unit and description. Okay, so these are all the keys. Okay, so keys look okay. Switch on description. Let's go ahead and try it one more time. Okay, so my breakpoint was hit, and go ahead and continue. All right, so it's being called from here. Okay. Okay, so I went ahead and debugged this further, and I found out that from the network manager itself, the spelling for forecast, I think, is wrong. That's why it was throwing an error. So let's go ahead and take a look at our model for weather response. And I think what I did is I forgot E in the forecast. So yeah, okay. So I'm gonna put the E, and I'm gonna remove all the debug and go ahead and stop. And basically what I'm going to do now is I'm going to simply build it and wait for it to load. Okay, so it's throwing an error because yes, of course. Okay, let's go ahead and build. Okay, yeah, forecast, and forecast. Let's go ahead and build again. Okay, seems to be building now. So yeah, that was my bad. Made a mistake. Okay, so now the weather is being displayed, and what we can do is we can change the custom location. And let me see if I can actually change this. Yeah, there you go. So now our weather is loading according to the location. So as you can see, the location is being tracked right now. Okay, so with that, yeah, we have come to an end of this video series where you learned how to build a weather app on WatchOS using Locations API and Little Software's weather API. Okay, so hopefully you enjoyed the course. Thanks again for your support, and I will see you guys in another video series.